Hello, grade 11s. I will show you how we can do the homework questions from last week. First question. To find the 20th term, we can simply count on the difference. So the common difference is plus 6. Using the n-term formula, then the 20th term will be u1 plus 19 times the difference, with the first term being 9. So therefore, this will be 123. Question 2, fill in the gaps. So you can, well, guess and check, but of course there is another way. If you count how many times this skips over, you will see that there are going to be 6 gaps. 1, 2, 3, 4, 5, 6. So you can think of the first term is just plus 6 times the difference to get to the last term. So you can set it as this equation here. And moving -3 to the right, dividing by 6, you get 2.5. So now I can just add 2.5 to each. I'll underline the terms that are missing. And voila. Question 3, we can use the similar technique that we just did in 2. So instead of using simultaneous equations, which I've shown you in class, we could approach the question like this. We have the 10th and the 14th term. In other words, the 10th term plus 4 times the difference will give me the 14th term. So by sticking in their respective values, we can manipulate this to give me 13/4. If you like, you can change it to decimal, 3.25, and that's the common difference. So question 4, again, we can use the same technique. We can say that 59 term plus 41 times the difference will give us the 100th term. Substitute. Now I'm going to change this to improper fraction because improper tends to be easier to work with if you have to add and subtract. You may disagree. That's okay. Now when I move 1/10 to the other side, I'll also put it on top of 20 as the fraction's denominator so that I can combine them. And then if I divide 41, this will be -1 on the top and 20 on the bottom. You can change this to a decimal and then go from there, but I'm going to work with fractions. So I also need to find first term. Using one of the terms, so either the 59th or the 100th, I'm going to use the 59 term and just write down what the relationship is with the first term, which is the n-term formula. So u1 plus 58 times the difference, so always one less. Then plugging in what we know. That should be, let me simplify it, so this becomes 29/10. And move it to the other side. So the first term is 3. And we have question 5 coming up. Find the sum of the first 100 odd numbers. So odd numbers look like this. And then we want 100 of these terms. So I think the easiest way to approach this is to use the first term formula. I mean, first term and the common difference. So that means sum of 100 terms is n over 2 times 2u1 plus n minus 1d. And exactly 10,000. You could also write down what the last number will be after, well, what's the 100th odd number. But some of you may not be so sure, is it 199, is it 201, or is it something else? But if you do actually get to 199, then you will also have, so if you know that this ends at 199, then you can use the term formula, sorry, the first and last term formula, which is this. So only for the more adventurous ones who can easily figure out what the 100th odd number is. So let's write down or, because you don't have to do both. All right, so we have a series with 20 terms. First term is negative 50, last term is 83. So it seems like it's time for the first term, last term formula. Let's substitute what we know. We know n is 20. We know first term is negative 50, and we know last term is 83. So we want to find the sum of the series. So basically everything is given. So that's just 10 times 33, which is 330. Thirty numbers are in an arithmetic sequence. The sum of them is 270, and the last number is 38. What is the first number? So again, we can use the first term, last term formula, but this time we are substituting different givens. We know the sum is 270. We don't know what n is. We also don't know what the first term is, so technically that's not very helpful here. So what you want to do instead is, oh, you do know what n is. Whoops, I misread the question. 30 numbers. So let me just replace these with 30s. So now you're only left with u1, which is what we're looking for. So let's manipulate. Now, because I see immediately that 270 can be divided by 15, so I'm going to divide out the 15 instead. You could just expand out to the right-hand side and then move the 570 to the left, which gives us negative 300, and then divide out. So you will still get the same answer. Okay, but on the left-hand side, so notice that 270 divided by 15 will be 18. So then minus both sides by 38, I get negative 20. So either way, do you know the way? Where did it go? Oh no, we got decimals. Well, decimals are just numbers. How many terms does it take to exceed 100? So first thing first, common difference is 0.3. So it's like one of those questions in class where I ask you to find the number of terms such that the sum is below 100, and then give me the next number that goes above 100. So here, let's just write down the nth term formula, which is u1 plus n minus 1 d. In class, I think I've also shown you the inequality way, so maybe I will do both. Let's just solve it purely by algebra because some of you are quite lazy like me that you don't want to take out your GDC to do. So what you want is, you basically want this. This is a sum, right? You want this to exceed 100. So we just pretend that we can actually pretend that equals to 0, equals to 100. Okay, so for the sake of simplifying question, you can let it be exactly 100 and then see what that n value is going to be. If it's in between two numbers, then that means you need to take the next available number, the next whole number. So you always have to round up. But to be correct, you actually have to use the inequality sign here. So here we can distribute the multiple here. And then I'm going to isolate n. So notice that 2 minus, so these two terms is just 1.7. So if I move it to the right hand side, it becomes 98.3. And then I just divide both sides by 0.3. I said I don't want to use my calculator, right? But I still have to use my calculator here. Well, at least it's not as tedious as if I were to graph it. And my goodness, I'm so glad that I use this way here. Okay, so if there is a term so that it gives us, exactly 100 as a sum, it will be, somewhere between 377 term, 327 term, or 328 term. So we want to round to the next number. What about the GDC method? Oh, I totally forgot about that. So GDC method is, where is it? Just wait for it to load. Come on. Park it here. Okay, so first of all, you will take the n term formula, which is this part here, this part here, this part here, and just input it. 2 plus n minus 1 times 0.3. And then we want to go to table of values, right? But the problem is, look at how big this number is. And keep going down until you find it. Good luck. I mean, the emulator is probably faster than what your GDC is capable because it just goes as fast as how fast you can click, right, on the down key. But you'll get there eventually. So on test, usually S will not be anything more than 50. So you don't have to scroll down in eternity. But over here we have come on. I want to copy this, but it's not letting me copy. Why? Oh. Actually, do I need to copy? No, since you're watching the video anyway. So anyway, on the GDC, I have the first 327th term to be just below 100, with the next additional term to go past it. So therefore, n is 328. So this is from GDC. put it away for now. And on to the next question. Here we have a tiny bit of applications of arithmetic series. So the book used progression to represent the same thing. So Brian, Melissa saved $50 in the first week. So that's the U1. 55 in the second, 60 in the third, and so forth. So you should notice that the common difference will be 5. How much will they save in 10 weeks? So I want S10. So we start with $50 in the first week. And then this will be 10 minus 1. No, so that's the end term formula. Actually, it is right. I want the end term instead. Whoops. So end term formula will be u sub 10 equals u1 plus n minus 1d. Can I just replace this with 9d and the first term being 50? That's what's nice about videos, because you get to see what I changed. If you just look at the notes, then you don't know what I actually did. This will be 95. And then let's just stick a dollar sign there. And to answer the second part, how long will they have to continue so that they will save $5,000? Actually, you know what? I was wrong. I'm sorry. It's just how much would it save in 10 weeks, not in the 10th week. So we are actually summing up the first 10 weeks. So here we have n over 2 times 2 u1 plus n minus 1 times d. And that should be 725. So how long will it take so that the target is to save at least 5,000? So again, you can do inequality, you can do calculator. So from now on, I will just do inequality, because you can always just stick the first line, which is your n-term formula. The nth sum formula. Sum of n-term formula. So n over 2 times 2 u1 plus n minus 1 d. We want this to exceed 5,000. So here we can manipulate this. And I already see some quadratics going on. Now I'm going to move the 2 to the other side by multiplying by 2. So then I'm left off with just the above, no fractions. So on the inside I should have 5n plus 95. And then let's expand this out. There's 5n squared plus 95n. And then I'm going to bring 10,000 back on the left-hand side, greater than 0. Now, we haven't done quadratic inequalities yet, but we will actually. So here, we can factor out a 5, and this will be 19 minus 2,000. And I'm pretty sure this is not going to factor out nicely, so I'm just going to use the quadratic formula. So my A is 1, my B is 19, my C is negative 2,000. So if you remember the formula, it's negative B plus or minus square root of B squared minus 4AC all over 2A. Substituting these, we have that. So I do need a calculator for this part of the equation, especially the square roots, because it's not a perfect square. So I have this to be that. So the two arguments will be either this, which I actually don't care about. I know that's a negative number, or this here. So I know I'm going to reject this for sure, since I can't have the number of terms to be a negative. So I would do the second possibility. This gives me approximately 36.2. So just like before, I'm going to round it up to 37. Okay, so 37 weeks. So if you're not very good with quadratic inequalities and you have a choice because this is like a paper 2 question, then go ahead and just put this into the GDC. And then you will scroll down the table until it goes above, was it 5,000? 5,000. Okay. We're almost there. Question 10. I remember there's a long question coming up. All right. So part I. How much does it cost to print 500 cards if you start off with a base of $45 plus 2 cents per additional cards? So 500 card would just be 45 plus 0.02 times 500. It's just easy math. I mean, that's just 45 plus 10, which is 50. Yeah. This one is an odd one because, you don't even need to know sequences and series to actually figure out the answer. How many cards can a customer buy with $100? So you can think of this as, well, 45 plus 0.02n, the total cost, right? And you want that to be 100. So this is like an application of this sequences, arithmetic sequence. But of course, they don't tell you what's the first term and what's the difference, right? So if you really want to label these, this is technically the first term and this is technically the difference. Yeah. And then this should be, what's 55 times 50? 2750 cards. There you go. It's quite cheap, assuming that that's American dollars. So that's like 15 cents in Hong Kong. This is the one. Man, just look at this. I don't even have space to write. So I'm going to write on the side. I have to read the question. I should have read this before. But just look at the picture, I can sort of deduce what's going on. So you have, well, let me just read. Child on the left-hand side has a ball which he throws to the next child in line. So they are playing toss. So that means this is 1, 2, 3, 4, and so forth. Okay? So what do you want? If a total of 5 children play and they make the least number of throws so that only the leftmost child touches the ball more than once, what is the longest single throw? What does it even mean? What does it even mean? Does it start with the left child? Yes. And then it's going back, right? So what is the largest single throw? Oh, okay, I get it. Just kind of odd. Basically, you want 5 children, just like this picture here, right? So what is the shortest throw? So if you throw to any of these guys here, all right, that's going to be quite far. Basically, the answer is, if you want the largest single throw with 5 children, is just to toss it to this girl, right? So then when she tosses back here, right? He will be touching the ball twice, so more than once. It's just a really awkward question to phrase. So here it's just 8 meters. And then what is the total distance traveled by the ball? Um, but they all want to actually. Okay. So, man. So it's that same diagram that I've drawn. Uh, in order to have 5 children involved, basically just worded the question like that. What is the total distance? Right? So notice that each time, each child only gets to touch the ball once. Okay, only once. But this poor guy gets to actually touch it 4 times, plus the initial time. That means he's the only one who is going to be holding on the ball more than once. So they want this total distance. The easy way is just to do 2 plus 4 plus 6 plus 8 for each forward toss, and then times it by 2 for the return, which is 20 times 2 meters. And then we have the same question, but with 7 children. So that means you do boot, 2 more. So what is the total distance traveled that ball? This is a good sort of number pattern building exercise. So that means I have to add 10 and 12. And that should be 6, 12, 20, 30, 42, 84. And then if n children play, derive a formula. Okay. So if you haven't seen yet, for 5 people, okay, this is for 5 people. This is for 7 people. Notice that I always have 1 less. Okay, however many people there are, it's always 1 less the number of people for the number of terms. So therefore, if I have n people, I should have 2 plus 4 plus 6 plus blah blah blah, with n minus 1 of these here. Okay, I mean there's n people, but there should be n minus 1 terms for n people. That's the pattern. Because the first guy doesn't have to toss it to himself. I mean, if he tosses it to himself, it will just be 0. Well, technically, if you're tossing upwards, it's still going to be some distance travel. But just take the first person away. So that's sort of like the idea here. But how do I actually sum it up? This is U1. Difference is 2. So the n-term formula would just be UN equals 2. Oh, wait. They want the total distance, right? Oh. So it should be... Yeah, sure. So we want to go from 2, 4, 6, 8, 10. And then we only want to do it for n minus 1 terms. So therefore, this will be... Let me just write down the n-term formula. It's U sub n equals U1 plus n minus 1d. So the first term is 2. We have, well, exactly n terms, so n minus 1d. So this simplifies to 2n. Okay, but we are not done yet. Remember, we need to include times 2 here. So therefore, this will be 2n times 2, which is 4n. I did something wrong. I did something really, really, really wrong. Because I should have done the sum. Oh, man. Oops. Because I'm adding them. So this should be a S sub n. S sub n is n over 2 times 2u1 plus n minus 1d. So n is still n. And, well, actually, n is not n. So n is n minus 1 because there's only n minus 1 terms here. So it's kind of odd, the index here, because they don't actually correspond. So to make it simpler, for n people, can we just write it down like this? I will write down a subscript. So here, n actually is n minus 1. Okay, remember, there are n minus 1 terms when you have n people involved, but we are only counting the terms. We're not counting the people. So every time I see n, I'm going to replace it with n minus 1. So this will be n over 2 times 2u1 plus n minus 1d. So the first term is 2. And here, this becomes n minus 2 inside. And difference is also 2. That's 4 plus 2n minus 4. So this cancels out. Times 2n. I can simplify this here. So this will be n bracket n minus 1. I'm still missing something. I am missing the times 2, of course, yeah. So the total distance then. So the s actually represents this. This represents the s part. But the distance, I actually have to do s times 2. So s times 2. Therefore, this will be 2n bracket n minus 1. You can expand it if you like, but I like to just keep it in this form. Whew. All right. D is to use the formula to find out how many children do we need so that the ball exceeds 100 meters of travel. So we already have the formula here. So basically, we need to just set it greater than 100. So again, you can use quadratic inequalities or you can use a GDC. But either way, okay, you can factor this again. So I will just use quadratic formula. N is, so let's label the ABCs. A, B, C. So this negative b plus or minus b squared. Remember, when you're substituting a negative values, make sure you put them in brackets. Minus 4ac all over 2a. So we have 1 plus 200, so 201. So therefore, I can't have this negative. So if we try this first option, you know this will be a negative number, so we reject it. Reject. Keep the second one. This is approximately 7.59, so therefore, that little? Can be. Okay, wait, that's exactly what they have before. Eight people, right? Oh yeah. So for 7 children, you have 84. So the next one would just be plus 14 plus 14. Oh, yeah, I should have just done for that. Oh, anyway, so 8 people. And then E. The children can all throw the ball 50 meters at most. What is the largest number of children that can play the game? What is the total distance? Okay. So first of all, we want to figure out where in this curve will that be 50 meters. So again, every children will increase the distance by 2 meters. So you will know that he can only throw to the 25th children away, right? So therefore, the number of children that can play should be 26. Do I need to draw a diagram? Sounds dumb though. So you're the first person. Every time he throw, you add an extra 2 meters. So to reach a total distance of 50, Therefore, you should have 25 children here. 25 children, not including the first children. So therefore, this will be 26 children can play. Rather than using the formula, I think just looking this in this sense is easier. So what's the total distance that they can throw? So they are limited to having 26 children play. We can use the formula again. We have the sum formula here. It's just right there. 2n times n minus 1. So we can just go 2n n minus 1. So it's nice that we have a formula. Otherwise, we'll have to derive it again and again and again and again and again. And we have 1,300 meters. Man, I don't think I can throw 50 meters. How far can you throw? Okay, finally, we have the last question. The summation one. Now for summation questions, I will recommend you do the first and the last term. So here, when k is 1, that's 1. And then when k is 2, I'll just write down a few terms. So when k is 100, then this will be plus 100. So I'll use the nth term formula for the first and the last term. N over 2 times u1 plus un. And this should be 50-50. This is a famous sum from Gauss. Next one. When k is 1, we have, 2 times, I'm just going to substitute the whole thing. 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. Blah, blah, blah. And now substitute the last number. 2 times 100 plus 1 is 201. So we'll use the first term, last term formula for S. This will be 3 plus 201. (204). There you go. And then for C, k equals 1, so 3 times 1 plus 5 is 8. 3 times 2 plus 5 is 11. Plus dot dot dot. And then we place this with 51. 3 times 51 is 153. Plus another 5 is 158. Now this time we only have 51 terms. From 1 to 51, there are 51 numbers. So n over 2 times 8 plus 158. Unfortunately, I cannot simplify the fraction in the front, but I could divide this by 2. Oh no, what's the answer? 4650 4721. 4721. No, that can't be it. No, I did something wrong. 4150 plus another 83 should be 4233. All right. So that concludes the homework portion for SL. Now for HL. Question 13 and 14. So for SL, you can try if you like, but don't really have to. So what's going on here? Well, first of all, we need to replace these into here to see what they are actually referring to. So here we have negative 3 plus 4i plus 12 minus 3i. And then this gives us 9 plus I, or just I plus 9. So that means the first term is 9 plus 1, which is 10. When I is 2, we get 9 plus 2, 11. Substituting the last term, it should be 9 plus 10, which is 19. So this is sum of the first 10 terms with this to be the first and last term. Here you go. For B. So again, let's see what the inside is. It's 3 times UI plus 4 times VI. Let's put another bracket here. What's this? Negative 9 plus 12i plus 48 minus 12i. The i's cancels out. So this is just 39. So what's going on here? Because every time you put in I, it's still 39. So you can think of this as like 0i. No matter what you substitute, it's always 39. So basically, it is just 39 plus 39 plus 39, 10 terms. So this is just 39 times 10, which is 390. It's a constant series. Not very important, but it could be nice when you have a question like that, because it's just taking the number of terms times what that constant term is. And for C, oops, this is negative 3 plus 4i. This is 12 minus 3i. So we need to do some foiling here. So here we go. First term, outer term, inner term, last term. So we can only group the middle two terms. Okay. Unfortunately, this is not a arithmetic sequence. So if you write down a few terms, you will see that the first is going to be negative 9. And the second term is something. So you actually have to list out all the terms in order to figure out what the answer is. So for this question, I would say you just stick it in GDC. So this one, use a GDC because not linear. And if I do so let's just show you what you can do again. We can go to summation x1 to 10 negative 36. Make sure you use a negative for a negative, otherwise GDC will go bonkers. That's not right. Checking the answer, and that's not right. So that means my foiling is wrong. Let me check really quick. Did I substitute these two things right? Yes. Ah, this should be a plus. Uh-oh. Why won't it let me? So let me replace that with 57 and see if it checks out now. Oh. 5, 7. Yes. So the sum is that. Okay. I mean, there is a way to actually calculate quadratic sequence, but we don't cover it in this course, neither in the HL content. And for the last one, manipulation. Show that u sub n is the same as Sn minus Sn minus 1. So you can literally just do it like this. This is sort of good for SL kits as well, because it's a simple proof, deductive proof. So in order to prove that one side equals to the other, you usually start from one side. And usually the longer side, the one with more terms, is easier to actually combine into something simpler. But it's not wrong to say that you can start from the left-hand side to the right-hand side. But in this case, it's really difficult if you don't know what you're doing. So here I'm going to start with the right hand side. Sn minus s sub n minus 1. So I'm using the n term formula. This is 2u1 plus n minus 1d minus can I just write down n minus 2 here? Because n minus 1 minus 1 is n minus 2. So we need to show that this is the same as u sub n, which is quite annoying, don't you think? Yes, this one is really annoying. It's actually so obvious that u sub n is just s sub n minus sn minus 1. But okay, here we go. Can I make this simpler? Ooh, I don't want to do it this way. What can I do? Because there's no un here. I have to use un somewhere here. Maybe it's easier if I use the first term in the last term formula so that u sub n is included. Okay, let me delete this. So I'm going to use I think this formula will be easier. Now, do you agree that u sub n minus 1 is basically just u sub n minus 1 times the difference? So I'm going one term back. So that means I can replace this with u sub 1 plus un minus d. Maybe I should expand the whole thing out. I know there's an easier way, but you may not be able to see what I'm doing. Now this is the annoying part because there's so many negatives floating around. So what I'm going to do is I'm going to write it like this. This is the same as n over 2 minus 1/2. Okay, now I can expand out the later parts. So let's expand out n over 2 first. I'm going to keep a bracket because there's a negative here. So this will be n over 2 u1, n over 2 un, and d over 2. Okay, so that's the first one here. Now so what I'm doing is I'm doing this, this, and that. And with this, I have a negative for each term, so it will be a minus first of all, and minus for the second one, and a plus for the last one. So let's distribute out the negatives in between the two parts. Now you see that there are terms that we can cancel out. For example, this, let's not do arrow. this and that, this and this. And then we have what? That's it. But that should be u sub n at the end. Am I missing something? This should cancel out. Oh, okay. I think it's embedded here. So let's just take these last four terms. This is basically nd plus u1 plus un plus d all over 2. But do you remember what u sub 1 is? So u sub 1, well, u sub n is u1 plus n minus 1d. So we need to do some collections here. This is technically u1 plus nd plus d plus un. Now if I factor out a d, my sign is wrong. This really should be a minus d. How come I have a plus d? Oh, because I forgot the minus here. This should be a minus d over 2. So this should be a minus, this should be a minus. So I can factor out d. But this part here is just un. So this is just un plus un all over 2, which is un. Whew. Okay. So that's the first part. Second part is actually quite easy, I think. Now that we know what un is, using this un here, find the arithmetic series for u sub I, or show that u sub I, given that u sub I is that. What? Find the general term u sub n of this, given that it's n over 2, 3n minus 1. Oh. I think this one might be a bit challenging as well too. So we have to assume, well, for arithmetic sequence, this will take the form of ax plus b. So what do I want to do here? Okay. Arithmetic progression or series has to take the form ax plus b. It's a linear. So because I haven't taught you how to sum up this, it will be quite challenging. We have to find u sub n given that, right? So we want to find this here. We want to find ab so that that equals to, n over 2 times 3n minus 1. So what you could do, maybe you can get some hints from part A. Exactly, yeah. So from part A, we know that u sub n is Sn minus Sn minus 1. But Sn is, using summation notation, it's just that. And then from this is just that. So if you actually list out all these terms here, actually that doesn't help you much, does it? Oh my goodness. No. I'm sorry. That doesn't help. I thought it does. So maybe we do need to approach it the first way. Okay, yeah. We do have to assume the first form here. Okay. So therefore, the first term here will be, so if I let, well, there's no more i's. So I need to replace my x with I, ai plus b. So that means the first term would just be a plus b. So if I let I equals 1, it will be a times 1 plus b. When I is 2, I have this. Plus 3a plus b plus 4a plus b. And then we want to do it for n terms. So that means n a plus b. Okay. So this is full expansion. Then this, if I use the S-term formula, this will be n over 2 times the first term, u1, plus the last term. So let's simplify this a little bit. So this will be na plus a plus 2b. So therefore, we have yeah, this is it. Okay, so we know that this simplifies to this, and then now we are comparing to the green part here. We know that this has to equal to this form here. So that means the inside has to agree as well. There's only one term with n, it's the first one, so we can say that n times a has to equal to, so we're just matching this. N times a has to equal to 3n, and a plus 2b has to equal to -1. A plus 2b equals -1. So the first one is easy. If n times a is 3n, I can rewrite it as an equals 3n. So therefore, we have a equals 3. And if a equals 3, I can substitute it here to get 3 plus 2b equals -1. So therefore, b is -2. Do they just want a and b or what? Oh, they want u sub n. So annoying. So we have a equals 3, b equals -2. So therefore, the u sub n is just ai plus b, right? So substituting that, you get 3i. Well, sorry, let me change it back to n. Okay. 3n minus 2. Geez, all for that. All right, so that concludes our homework from last week. Yay!